Hello, my name is Josephine Seifert. I'm from SecuStack, which is a daughter company of Cloud Untitled. Cloud Untitled operates public cloud data centers, and so we also have customers coming to us and asking some questions for OpenStack, what we operate. And one of these questions was, can OpenStack actually have a more user-controlled key management? Because right now all the keys are in the cloud, and the customer and the users wanted to have the keys more up to them or more control over the keys. And we actually started digging into the OpenStack code and made two more approaches to key management for OpenStack, and I will present these two approaches today. But first, let's have a look at how encryption works in OpenStack now. At first, there are some necessities we have to fulfill. We have to have a key manager, for example, Barbican, which actually does the software, generating keys, storing keys, giving out the key handles, and so on. And to effectively store these keys, it's good to also use HSM, which works with the key manager. Additionally to that, you have to have a few configuration and operational tasks. Like if you want to use volume encryption, you have to actually create an encrypted volume type and configure the URI in all the configs to use the key manager, so in that case Barbican. And that brings us to the workflow. Here we have an example workflow of how volumes are encrypted in OpenStack. First thing is we want to create an encrypted volume, and we use the CLI command OpenStack volume create -- type, and here we use the formerly created encrypted volume type. And what happens then is the key generation, which you see on your left. OpenStack sends a key order to Barbican, and Barbican automatically creates a key and stores it. When the key is used, for example in OpenStack server create from that volume we just created, so we have an encrypted server from an encrypted volume. What happens with the key is that the OpenStack service, in that case Nova, sends a request to the cloud key manager, and Barbican sends the key back, so Nova can use it. After that, somewhere you delete the volume, and the key is also automatically deleted. And the first thing, we wanted to have the user just have a little bit more control about what key is generated and what key is used when. We just give the key generation to the user. Either the user creates the key and loads it up to Barbican, or the user actually does the command OpenStack secret create, which creates a key in Barbican. Then, whenever an encrypted volume, in that case, should be created, we use a reference to the key ID, and the key manager actually gives the key to Barbican, to Cinder, and the volume is encrypted. In that case, the user is also accountable for deleting the key. The other, a little bit more complex approach is the end-to-end key transfer. Actually, it works a little bit different because we had to define new states. Normally, in plain and key manager mode, you create a resource and it goes to active state. We don't want to do this right now because we want to transfer the key, which is held by the user, only to the dedicated host on which the server or the volume is spawned. So we actually create the server or the key and it is scheduled, and then we stop in a provisionable or ready to spawn state where we know the direct host. And that's how the workflow is. User creates the key. User does the command OpenStack volume create and indicates that he wants to use the key transfer. And then the create stops at the provisionable state. So the user has to actually do the provision step when the host is already known, and he can transfer the key directly to the host, which is only then used for the encryption of the volume and dropped later off. Also, the deletion of the key is up to the user, and this doesn't have to have anything to do with the cloud. Here you can see I've actually highlighted this provision step because it's an important step. That's for the volume. The same thing goes for the server. We use the OpenStack server create -- volume and use an E2E encrypted volume. Now the create stops at that point where the host is scheduled. We know which host the VM will be spawned on. And then we use the OpenStack server spawn command and give with a key path. Or, as you can see in the comment down below, a key prompt parameter. So actually, we have the possibility to specify the key in the key path or just to prompt from the CLI. These are necessary instead of just having normal server create because of the decryption of the volume. When you create a server, you have a decryption layer on the volume, which is then used to write into the volume. And for encryption and decryption, both the key, which is held by the user, is needed. That's why we had to split up the creation process. Coming to an end with this short presentation, I just want to summarize again. On the app, we have normal OpenStack way, which is completely automatic. Automatic key generation, automatic usage, and automatic key deletion. Our users wanted to have more control. So our two approaches are named user-involved key management, because the user actually knows when a key is created because he creates the key, either themselves or on the host. The user knows when something is encrypted with this key because he specifies the key while the encryption process. And the user has to delete the key. If the user doesn't at all want to have a key management in the cloud, which also was a request for us, he can use user-controlled key management, which is completely out of the cloud. The only time the key is actually used is in the middle case, while the usage, and it's only timely stored for the encryption. After that, we overwrite it in the cache. And that's all. Thank you for listening, and if you have questions for more details, I'll be here. Thank you.